disc, it scatters. And the radiation of the sun that is coming will fall on the disc here, and it will be diverged to this glass here. And on the glass, we have a mirror, a minute mirror, that will converge all the diverged radiation that is coming from the sun on the disc to the mirror to a point. The reason being that the rays, the radiation that will fall on the disc will be scattered, but this mirror will converge everything together to a point, and this mirror will now transmit the heat into this black body. This is known as a black body, and black body is able to hold heat radiation for a long time. It absorbs any heat placed on it, and when the black body absorbs the heat, it keeps the heat and warm it up. And when we tested this project, its temperature rises to 60 degrees centigrade, and because of the environment in which we are, it can be improved to perhaps 100, even more than that. And we tested it with egg. We boiled it on it, and it boiled very well. And we also boiled water on it to an appreciable degree. And this project is an ongoing one, which can be improved to generate it. And it is very useful for everybody because of the electricity problem we have in our country, in rural area, even in urban city. This can be used in the household, in the industry, and perhaps with the farmers as well. In household, you can use it the housewife can use it to heat up the environment, to cook as well. In the farm, it can be used to dry up our crops, to preserve them for a long time. And even in hotels, it can also be used as a sort of generating heat to appreciate what they are having in their environment and to make use of it. And as I said earlier, it's an ongoing project which can be improved, and doing that, you can increase the temperature to perhaps more than 100 degrees centigrade. The basic principle is very easy. The sun, we all know that it hydrates energy, and the energy it hydrates, we convert it to heat energy. As I said earlier, the radiation will fall on the disc, and the function of this minute mirror is to converge all the diverted energy, the rays, to one point, so that it can generate the heat at one point, so that it won't be scattered. If it's scattered, we won't have a uniform heat, and it won't heat up what is inside the black body. So the mirror here will converge all the rays to one particular point, and it will heat up anything that is placed inside the oven.
In the HND2 class, Miss Otisi Justina chose to present the Laspotec version of the Yam Pounder, while Vivian Macaulay presents a group project in the form of a cowpea thresher.
This machine is called Yam Pounding Machine. The components include the electric motor, the connecting rod, the bearing, the stainless steel, the stand, the switch, the valve. Then inside the pot, which is made of the stainless steel, we have the angular rod, which is being connected to the shaft. So when this is the cable which is connected to the electricity, first of all, before our machine work, we'll have to boil our yam, whether by stove or with the use of gas cooker. After the yam is boiled and it is fully boiled and you know that it is soft, then we do what? We open our pounding machine. We make sure it is cleaned, free of dirt and every kind of organisms. So we pour our yam, our boiled yam in it. We cover very tight with our bolts, very fixed tight, to prevent escape of steam. Escape of steam from either side, because it is pressure valve. So we plug our cable, then we on it. Then our switch, we on it too. Then the electric motor it converts the energy. Then it begins to rotate. It gives the power here. Then the shaft begins to rotate. Then it also moves the connecting rod here, which is in rectangular shape. First of all, it begins to blend it. We should remember that our pot is heat sealed to prevent any form of escape of steam, to make sure that the steam is being maintained in the pot. So the shaft begin to rotate, and first of all it begin to blend the yam. After blending, then they begin to form some kind of pastry sauce, pastry kind of material. Then after it begins to make them in uniform. So this takes about 5 minutes before the completion of pounded yam. We have different kind of stainless steel. This one is much more expensive. So it's because of this is an edible substance. That's why we use the stainless steel material to construct the pots.
The purpose behind the construction of this machine is to help in reducing labor pains that women particularly go through in the process of getting the beans ready for food. And we know that here in Nigeria, beans is one of the major source of protein aside from meat and other things. And a lot of people cannot actually afford meat. So to make it easier for the beans to be able to get to our table in time, we're looking at all the problems that women go through in order to be able to put these beans on the table for us to eat. That was what made us think about constructing this machine you see here. This is actually a cowpea thresher. It's being operated with the aid of this engine here. The engine has a power of 5.5 horsepower. The working principle is this, that actually the part, this is the hopper. In here we have a threshing drum, and it has a sieve and also another hopper here, the outlet where the bean comes out from. When the engine is turned on, the rotation from the power from the engine also helps to agitate this, which now helps the hopper inside to turn. Now the beans is poured in through this. As soon as the beans is poured in, it has to be covered so that the pressure from there doesn't push it out again. Now the threshing drum rotates with the help of the engine that is running. As it rotates, the drums will beat on the beans to help dehusk the beans. By dehusking, we mean just to remove the beans, separate it. Now because it has a blower, the blower is going to do something. It's going to blow off the chaff. Because the chaff are a lot lighter than the beans is heavier. So the beans will drop through the holes. Now the sieve has holes. Actually, we graded it with 7 mm. That's looking at the sizes of the beans we have. So as it drops, we can collect it with our bag down here, and the chaff will be blown off. So that's just a simple working principle. This is a mild steel. We made use of mild steel. The thickness is about 3 mm. We drilled the holes of this considering the fact that the beans comes in different sizes. So we had to drill it, and like I said earlier, we used the 7 mm to drill this. Without this pulley, really, the whole machine is useless, because that's what connects the power from the machine to the threshing drum. The diameter of the whole, the same mild steel we use in the construction of the whole thing, that's what we also use for the chutes, as well as, but we had to use a thicker, this we usually call it angle iron, because that's what holds, so that when this is rotating, the power doesn't throw away the machine. So we had to consider the weight too in getting the size of that. Okay, so I'm going to open the hopper so I can pour this in, and Emmanuel here will help us turn the machine on. Okay, so we are doing that. All right, so Emmanuel, you can turn it on.
The Central Wood Workshop is no doubt in the Civil Engineering Technology Department of the LASPOTECH. The unique thing about this workshop is that it serves as a hub that services all the engineering departments of the School of Engineering. On offer at the Wood Workshop are Eric Adesoji's computer table and another group project, which is construction of a concrete slab as presented by Banjo Oluwaseyi. Both projects are still under construction.